Hello and welcome to our online tutorials on C programming. In our first lesson, we begin by looking at fundamentals of computer programming. Then we take a look at introduction to C programming. So let's get started. Computers can do a wide variety of tasks because they can be programmed with more than one program. This means that computers are not designed to do just one job, but to do any job that their programs tell them to do. A program is a set of instructions that a computer follows to perform a specific task. Programs are commonly referred to as software. Software is essential to a computer because it controls everything that a computer does. All the software that we use to make our computers useful is created by individuals working as computer programmers or software developers. Now, before we proceed, it is important for us to be able to distinguish between object code and source code. Source code is the version of a computer program as it is originally written by a human computer programmer using a specific programming language, while the object code is the output of a compiler after it processes the source code. Now we have different types of different generations of programming languages. However, we are going to be looking at the first three, that is the machine language. In machine language, computers can easily execute programs written in machine language or object code. Here, programs are written in binary language. We talk over one-to-one mapping. One of the advantages is that programs can run much faster since no compilation is required. However, it's difficult to debug or maintain programs written in machine language. The second one is the low-level language or the assembly language. Now, to lessen the difficult task of programming in machine language, the assembly language makes use of mnemonic codes for representation of characters and numbers. So it is easier for us now to be able to debug compared to the machine language. However, there is need for translation. The third one is the high-level language. It allows us to create powerful and complex programs without knowing how the CPU works or without writing large number of computer instructions. Programs are coded in English-like language, and it allows program solutions to be specified in human and problem-oriented manner. We can develop applications much more faster. However, still there is need for translation. Now, these translators we are talking about, here we are saying because the CPU understands only the machine language instructions, programs that are written in assembly language and high-level language must be translated into machine language. Looking at the assembly language and the high-level language, in assembly language we use the assembler as a translator, while in high-level language we have two translators, that is the interpreter and the compiler. Now again, these translators, that is the assembler, is used to translate low-level language or the assembly language into object code. The interpreter translates high-level language to machine language equivalent object code, if you like, one instruction at a time, while the compiler translates the high-level language to machine language equivalent, that is the object code, and it translates the whole program at once. Now looking at the assembly process, number one, assuming that this is our program written in the assembly language, would need an assembler for it to be translated to machine language or the object code. After the translation has occurred, now there would be no need for us to be able to use to use the program written in assembly language further, because we need to use just the object code and it can be executed and the computer system can be able to understand it. Compiling process, assuming that is our program written in high-level language, we require a compiler for us to be able to get the object code, which is the machine language. Next time round, we would not require the the program written in high-level language instead will be executing the machine language without the need for compilation, and the computer system will be able to understand the program. However, much different. Given that this is our programming language, we would still require an interpreter for us to be able to get the object code. However, the process is much different, as I've said, because every time that you run this program, there will still be the need for us to be able to do the interpretation or to do the translation for us to get the machine code that can be understood by the computer program, the computer system. What are programming languages? A programming language is a formal language comprising of a set of instructions that produce various kinds of outputs. Most programming languages consist of instructions for computers. The description of a programming language is usually split into two components. That is, we have the syntax and the semantics. The syntax is the form or organization or the arrangement of the program code or instructions, while the semantics itself is meaning of the program statements. What are the advantages of high-level languages? So we are saying we have an element of readability. Programs are much more easier to read. We have maintainability. Programs are easier to maintain. You can make changes to a program much more easier compared to other programming languages such as machine and assembly language. And we have portability. Programs are easy to port across different computer platforms. Let's look at C programming itself. And we're seeing it's a general purpose and procedural computer programming language developed in 1972 by Dennis M. Ritchie at the Bell Telephone Laboratories to develop the Unix operating system. Why use C? It is easier to learn, number one. Number two, it produces efficient programs. And three, it can handle low-level activities. And lastly, it can be compiled on a variety of computer platforms. Now let's look at the structure of C program. We have the header section that contains the name, author, and revision version. We have the include section that contains include statements, or if you like, the preprocessors. We have the constant and type section. Here we have the types and the definitions. Here next we have the global variable section. The global variable sections, this is where you can find declaration of variables that will be identifiable all through the entire code. And we have the function sections. User can define codes within this section. And lastly, we have the main section. Now remember, in the main section, this is the first section, or rather, this is the first function to be executed when you run your program that is written in C programming. Let's look at the structure using a sample code. Now looking at this code, in the first line where we have #include standard input output.h, this is the preprocessor we talked about. It basically instructs the compiler to include a specific file before it can perform the process of compilation. We have the main function, and as we have said, that is the first function that will be executed when you run the program. We can have the display section, that is, within the body of the main function, we can have output using the function printf. And we can terminate the program using return 0. That terminates the program. We require a semicolon at the end of that statement. And lastly, we have comments. Comments are basically used for purpose of making the program much more readable. Now, the preprocessor directives, and as we have seen in our previous example, we have #include standard input output, and we have said what is basically happening within that statement is that we are telling the compiler to include a specific file, and we have specified the file as standard input output.h. In the main function, we say that will be the first function to be executed as we run our program. Comment sections, comments are ignored by compiler, they are never executed. They are basically used for purpose of making the program much more easier to read and much more easier to understand. The printf, we said it's for output. It's used to print characters, string, integer, float, octal, hexadecimal values, and so on the output screen. Basically, these will be the syntax for writing the printf function. And looking at the sample printf given there, that statement, remember we say that everything within quotes will always be output as it is. Therefore, it is going to output hello world. We have printf there. Again, it's going to output the area of the rectangle is. You can see we have a %d there, a representation of an integer value. So we are expecting the value carried by variable area to be of an integer type. We have another sample program given there. And if we look at first statement, that is a preprocessor directive, then we get to the main function. And inside, we have a declaration of variables, that is area and pi and radius. They are of float type. Now, these variables are local. They can only be recognized within the main function. And we have what? We have a computation of the area of a circle given radius 7 and a pi of 3.14. Again, looking at the printf, it will be able to output the area of the circle is. You can see we have a percentage. We have a percentage f, and what basically that one implies is that it's expecting a value that is of a float type. Again, what will be the output? The output is 153.86. Now let's look at the installation process. And to program in C, we need an integrated development environment. So we basically just go to Google, and on Google search we type IDE for C programming language. See what it gives us: different types of integrated development environment softwares that we can use for programming. But in this case, I prefer the use of Dev C++. It depends on your choice, so choose whichever you feel works best for you. So I basically just need to click on it. It takes me to the download page. Once on the download page, what I need to do is just click download. Let's wait for it. And the download process begins. Once we are through with the download process, we just need to click here, and then we can open to run the software itself. That is the executable file, and then we just need to click, and the installation process begins. Select the language that you prefer to use, and then you click OK. You agree, you move next. You select the location where you want to install your software installed, and then click on install, and you're done with the process. I'm not going to go ahead with the process because I already have the software installed on my computer system. But that's basically the process. To run our IDE after installation, we basically need to click on Windows icon there. Then it was Dev C++. Click on it to run it. There, we have it. It's running now. We come to File and then New, Source File. Alternatively, we can click on this icon here and then click Source File, and we have our first page where we can type our code. We are going to work with our sample program. So there it is. Hash include, we have the main function, and then we have our print hello there, return 0. Let's execute this program. For us to be able to execute it, we basically just need to click on execute and then compile and run. Give it a name, my hello, then click save, execute, run. Now it is running.